Okay, let's go ahead and take a look here. And so on my screen, I have two windows, two browsers open. The one on the left is me, the professor's GitHub repository for this class, right? So this is me, and last night I posted files for today's lecture, okay? Added lecture 1.1-2 and related files. So the way I number my lectures is the first number is for the week, and then the second number is which lecture in the week it was. So if it's the first lecture of the week, it's 1-1. This is Wednesday, their second lecture, so it's going to be 1-2, and so on and so forth. So 1-2 is going to be today's lecture, and I've uploaded some files there. So this is my repository, me, the professor, my repository on GitHub. This over here is, I'm pretending to be a student, and last time I said, I want you to fork my repository, the professor's repository. I want you to fork this. And it looks like some of you did. 32 forks have been created, which also means there's about 40 of you who have not done this yet. Okay, so please make sure you do this. And so over here represents kind of the repository that has been forked. And this represents the kind of command prompt of the student's account. So right now the repository is in my home directory, so I'm going to change into this directory 2022. So I'm going to do cd 2022, and I can just do tab completion. Now I am in the repository, and I can ask git status, and it reports that that we're up to date and whatnot. And part of when you fork this, you had to establish the upstream remote repositories, and I covered how to do that on Monday, or you can review that portion of Monday's lecture, but I can always kind of check the remote status, and I can see, so when you clone a repository, it's into your local computer, it's going to always establish the origin repository, and then what I did is I said you need to establish an upstream repository. Okay, your origin repository will have your student account, your GitHub username here, but everyone in the class, everyone's upstream repository should say SmilesChen 2022-fall, etc. Okay, so everyone's upstream repository should be this. Now what we need to do is we need to download all of the files from the upstream repository, right? So to do this, okay, it's just one line, okay? So here I uploaded 5 files. Traditionally, if I had posted this to Canvas or something, you'd have to go on Canvas and you'd have to download all 5 files individually. The beautiful thing about using Git is it's just one line to type, okay? You just do git pull upstream, okay? And specifically, we can say git pull upstream main. But I think I can just do, okay? So here I've done this, okay? Git pull, so this is, we're saying pull from the upstream repository, pull the main branch. And here it says, okay, I've downloaded IPython, I've downloaded the PDF, I've downloaded this HTML thing, I've downloaded these Python scripts, okay? And now, if I just kind of do ls, now we can see all 5 files have been added to my repository. And if I want to synchronize my my GitHub, okay, the student one, okay, then I'm going to just push. And by default, I can just do git push. If I want to specify that I want to do it to my own, I'm going to do git push origin, but by default, that's going to be it's going to push to your origin. So you can just do git push, and here it's pushing. Did that not work? Let me check. No, it did. Okay. I was expecting more stuff to show up here. But here it has pushed all of those files, and so now we can see my my student accounts repository now has all of this stuff here. Okay, and we can see, yeah, it has kind of pushed all of these things up there. All right, so I'll do this a couple more times, but I'm gonna, I guess I'll stop doing this, you know, in a couple of lectures here. But again, the commands, all you have to do is once you've established your forked clone, okay, once you forked it, once you cloned it onto your computer and established the Upstream repository, it's just really two commands, or really just one. Git pull upstream, okay, git pull upstream main, and that will pull everything from me, the professor's repository, down to yours. And then to synchronize your GitHub, you'll do git push. Yeah, question?
Do you need to add upstream every time?
You don't need to add the upstream every time. You just need to do it once.
Oh.
And then from once you have that established, then you can just do git pull upstream. Okay?
Okay.
Yeah. All right. I'm forcing you to use Git so that eventually you'll love it, okay? All right, and in the beginning it feels like, oh, why do I have to do all of this? Why can't I just right-click things on Canvas the way I like it? And it works, but it doesn't scale very well for, you know, more complicated things. And so it's a good thing. We'll get there. Okay, so here I'm gonna go back to, so I'm gonna exit my student virtual machine here, and here I am. So this is me on my professor's terminal. I'm in my thing. I can kind of show the contents of my directory here. And I guess I'm under the assumption that we've installed Anaconda on our computer, maybe, I hope. If you haven't done this, you need to do this. Okay, you got to search for Anaconda, and it used to be you search for Anaconda, you'd get like either a music video or a movie and things like that. But it seems all is well in the world now, and Anaconda now pulls up most popular data science. But okay, oh yeah, I guess, yeah. The poor actual Wikipedia entry for the Anaconda was even demoted, even behind, yeah, you'd get the 1997 movie. And okay, I don't know what happened to that music video, but yeah, make sure you go to Anaconda. You're going to go to Anaconda Distribution. It used to be Anaconda Individual Edition, but now it's just Anaconda Distribution. You'll download and install it, okay? And then, if you're on Windows, you'll probably open up Anaconda Prompt or Anaconda PowerShell Prompt. And to start it up, I'm going to recommend using Jupyter Lab. There's Jupyter Notebook. Jupyter Notebook is good. Jupyter Lab allows you to run Jupyter Notebooks. Plus, it also kind of has other things. So all you do is you just type in Jupyter spelled with a Y. And just Jupyter stands for Julia, Python, and R. Okay, that's where the name Jupyter comes from. Julia, Python, and R, because the notebooks kind of support those languages. But right now, I just have the Python kernel installed. But you can add like other kernels for the languages Julia and R and stuff like that. All right, so when you open up Jupyter Lab, this is what it looks like. And I opened Jupyter Lab from the folder that I'm located in, but you might need to navigate to your folder where the notebooks are. And so I can open up the notebook here. And I've also created a slide presentation with this, and actually, I think I want to open it in a new browser tab. All right, so this is, you are able to take these Jupyter notebooks and turn them into, slide presentations as well. There's a bunch of different tools out there. Another is a Visual Studio Code, and that also supports notebooks. And I'm not going to be super strict, but I think, but I'm going to kind of start off with Jupyter, and we're going to kind of work off of that. And if you want to use something different, I won't get angry with you. Okay, so here we're going to. This is going to serve as just an introduction to Jupyter and Ipython, which is kind of our interactive Python. So there's a few ways to run Python, and so if you installed Python directly, you might have gotten the Python interpreter. And actually, I forgot even how to start the Python interpreter directly. Let me see if I can do this.
Can you just type Python in the shell?
Yeah, so in here, if I type in Python, this opens up the Python interpreter, and you can tell this is your base Python interpreter because you get this kind of triple, greater than to kind of indicate where you are, and you can do something like 3 + 3, and you hit enter, and it says 6, and so on and so forth. I forgot how to quit. Is it just exit? Oh, exit parentheses. Okay, so and so that's just the base Python interpreter if you were to install, say, Python. I like using Jupyter, and you use kind of these cells, and well, anyway, we'll talk about it. Okay, so you can run Python directly in interactive mode. In general, I would say it's not kind of your the preferred method of working with Python, just because unless you explicitly save things and stuff like that, basically all of your work just will disappear as soon as you exit and stuff like that. So here, Jupyter allows you to kind of create scripts and allows you to kind of create these cells and store your code and look at the input and outputs and things like that. Okay. Another simple way to interact with Python and do things is just create like a text editor. Right, so you can open up a text editor, you can save your scripts, and then you can have a separate window with the Python at that command line, and you can just call Python to run scripts from the command line. All right, and that's kind of a very basic way, but it works. Okay, and some people kind of prefer that method of interacting. All right, and then there's kind of like full-fledged on the other end of the development spectrum. There's like these full-fledged integrated development environments like PyCharm, where there's kind of a lot of kind of nice features there as well. Jupyter Lab is basically, it runs in your browser, and it's kind of centered around notebooks and whatnot. And I like using Jupyter notebooks and whatnot because I think it's well suited for kind of the process of data analysis and data science. Because a lot of times when you're working with data, you want to just run a quick little command and see, like, let's calculate the mean of this column. I want to create a plot right away, and I just want to kind of take a look at how some of the stuff appears, and you want to get like quick responses. And notebooks are well suited for that. If you're going to say create a program that's going to be running, and you want to kind of, you could create games and stuff in Python if you wanted to, because it is a general purpose language, then certainly the notebook is not ideal for that. Okay, the notebook has a document structure where you're able to add basically your comments and your plots and things like that. So the notebook has, is structured like a document that allows you to run code. It's very different from a traditional script and things like that. So, when I give you homework assignments, I give them to you as notebooks because I think that makes sense. But again, when you're writing scripts and you're writing other kind of programs, you wouldn't use the notebook. Don't use a notebook for everything. It's not the solution for everything, but it's well suited for tasks in data analysis and data science. Okay, Jupyter comes pre-installed with the Anaconda distribution, and once you do that, you just kind of open up your prompt, you type in Jupyter Lab. If you only want to do notebooks, you can type in Jupyter Notebook, okay? When you're working in a notebook, you have command mode and you have edit mode, okay? command mode, you hit escape on your keyboard to enter command mode, and then to edit your cells, you hit enter return, and then it'll change kind of the, I guess, the color of your cell, and that's when you type things and it enters, kind of your code in there, right? One of the biggest kind of mistakes early on when working with Jupyter is not paying attention and typing in commands when you are like typing letters in, and it's like changing your notebook because you're in command mode and you were expecting to be in edit mode or something like that. Okay, so over here, what I'm going to do is I'm going to just kind of create a basic Python notebook. So inside Jupyter Lab, one of your tabs is going to be the launcher, and I'm going to just create a notebook here. All right, and so this creates a blank notebook. And here I am in edit mode, right? And I can type in something like 3 + 3, right? And if I hit enter, it just kind of adds more lines here. So to execute a cell, you have a couple options. One is control or command enter. The other is shift enter, and the other is alt or option enter. And they do very similar things, but things that are slightly different. So control enter or command enter will just execute your cell. Right, so it does 3 + 3, and you get 6. All right, no surprise there. Okay, now I want to add. Let's say I want to add a cell. Okay, well, you can do this by using the menu bar, and you can hit the little plus button, and it's going to add another cell. And let's say, all right, we want to do another calculation. Okay, what is 6 factorial? Okay, I think this works. Okay, and then and I can hit Control Enter. And it didn't like that. Okay, so actually we can't do that. Okay, but let's do some multiplication. So I'm going to do 6 × 3. Okay, I'm going to hit Control Enter, and it executes that. All right. Now, rather than having to use my switch from the keyboard to your trackpad or mouse back and forth, I strongly encourage that you learn keyboard shortcuts, and that way you can kind of just keep your hands on the keyboard and work quickly. So an important one is hit B, just the letter B. When you are in command mode, when you type in the letter B, it's going to add another cell. Okay, and if I type B again, it's going to add another cell. And I'm going to just keep typing B, and I'm adding a whole bunch of cells. Right? To navigate up and down the cells, you can use your up and down arrows on your keyboard. You actually don't even have to have your fingers leave the home row, right? So we all learned how to type, or do we still hunt and peck? But you can keep your hand on the home row, and you can just use the letters J and K. You don't even have to move them down to the arrow key, right? Because when you're a programmer, oh my goodness, having to move your hand 6 inches over to those arrow keys is frustrating. So you can just leave them there. You can use the letter K and use the letter J to kind of navigate up and down the cells, which is really great, okay? And if I wanted to edit one of these cells, I just hit enter, and now I'm in edit mode, and I can type in my thing, right? I can do 6 squared, so 6 ** 2, and I can hit command enter, and that executes it. Okay, and I can kind of go through and all of this. Again, one of the things that you need to know is whether you are in edit mode, where the cell is highlighted, or if I hit escape, I'm in command mode. Okay, and so don't get those mixed up, because if I expect to be in command mode, and if I wanted to say type in the letter B here, okay. If I'm in command mode and I type in the letter B, it's going to add another cell. Whereas if you're in edit mode, then it types in the letters that you have. Okay. So when you're in command mode, if you want to delete a cell, or here, before I get too far along, let me just make sure I'm kind of doing these things. So adding cells, will add a cell below. And if you want to like insert a cell above, okay, so when you're in command mode and you have it selected, you can type in A, and it will add a cell above. you can type in B and add the cell below. If you want to delete a cell, you have to type in D twice. So I type D, D, and it deletes these cells. D, D, deletes these cells. Okay, and that's how we manipulate things. Is this? Do I need to zoom bigger here? How do I guess we can zoom a little bit. I don't know if that's any easier to read. Okay, so this is, so here I am working in command and edit mode using J and K to navigate up and down the cells. And actually in Gmail, you can actually use J and K to navigate through your different emails as well, which is kind of nice if you want to stop using your arrow keys. And so again, strongly encourage you to learn the keyboard shortcuts rather than using the your mouse and things. Okay, you got cut, copy, paste. All right, and so notice cut, copy, and paste are X, C, and V, and these are kind of the same things that we're accustomed to, except normally on the word processor, like you'd have to hit Command X and Command C and Command V to copy and paste. Whereas in Jupyter, if I wanted to copy this, I can just hit C, the letter C, no command, and hit the letter V. All right, and it just kind of copies, and I keep hitting all of these things. If you want to cut, you can hit X or something like that as well, and it will cut these things. And so this is where, like, let's say you wanted to write the variable x equals 5, okay? And you do x equals 5 here, which is fine. But if you're in command mode and you start typing in x equals 5, what's it going to do? It's going to, like, cut that thing, and you go, oh, what did I just do, right? So so that's why it's important. Make sure you don't mix up being in command mode or edit mode, okay? To undo, you just hit the letter Z, okay? The letter Z undoes an operation. Yeah.
How did you get it to copy, like select multiple lines to copy this?
I didn't do that, but you can select multiple lines by holding down the Shift button, okay? And using J and K or your up and down arrows to highlight multiple things. And you can just hit, say, C, and then I can come down here and hit V and paste multiple cells. Okay. All right, navigating, you can use up and down arrows. You can use J or K. Right? When you're working in Jupyter, there are a few different types of cells. There's markdown cells, code cells, and raw cells. Okay? To switch, so when you create a new cell, by default it's going to be a code cell. And if you want it to become a markdown cell, you can type in the letter M in command mode, or you type the letter Y. And again, this is, one of those things where if you're in edit mode and you type the letter M, it just types the letter M. But if you're in command mode, you hit escape to get into command mode, you hit M, and it becomes a markdown cell. And the only real, what you notice is as a markdown cell, you don't have these kind of square brackets in front. And with a markdown cell, I think we're a little bit familiar with Markdown from like your other classes. It's similar kind of thing with R Markdown. So if you want to create a headline, you use kind of hash marks, and you say like this is, heading. This is heading level 2. Some paragraph text. 3 levels will be heading level 3. More paragraph text. And then, bulleted list, bullet point 1 and dash bullet point 2. And then to kind of convert from just raw entry here into to being rendered as a markdown text, you hit Control Enter, and it formats all of this, right? And then if you want, say here's bullet point 3, and if it's like you want to emphasize it, you can put little stars around it. So 2 stars makes it bold print, and 1 star makes it italicized. Bullet point 4, single star, command enter, and we have that. I'm going to go ahead and convert the next cell into Markdown. And again, you can also enter math by doing $ signs, and you can do something like the integral from x equals 0 to, say, infinity, x squared dx or something like that, right? And you're able to produce, pretty math print or something like that using, your LaTeX commands and stuff. And again, so this is what it looks like when it's rendered. And if you need to make edits, you can do, whatever you need to do that, right? So, see, this is not rendered, and then when you hit Control Enter, it renders the markdown into, whatever print you need to do. Okay, so that's markdown cells, and then you can kind of switch between markdown and code. So if for whatever reason you wanted to switch this to code, you can hit Y, and you can see it's a code cell because it's going to have these kind of square brackets, and M to kind of switch back to markdown, and you have that. Okay, so this is just whatever you have. Okay, heading levels, 2 hash marks, 3 hash marks, and so on and so forth. Other markdown basics, you can have bulleted points and single stars and double stars to make it italics and bold. And this is, if you needed to write equations, so this is your normal PDF and so on and so forth, and you can write all of this out, right? Okay, we all know like a little bit of basic LaTeX stuff, I think, maybe a little, or no? Okay, so if you're not familiar with LaTeX at all, just go on Wikipedia. I think there's wikibooks on like, here, hold on. So just wikibooks LaTeX. It's and there's a bunch of oh, this is like the mobile version. I don't want that. Okay, so the wikibooks on LaTeX, and basically your stuff is going to be on where is it? Where's the math stuff? Okay, technical text, mathematics. So probably most of the things will be under this mathematics section on like how to create symbols and equations and things that look like fractions and stuff like that. Okay, but that's beside the point. All right, so to run the cell, to run code or render the cell, we've been doing Control Enter. The one I like to use the most is Shift Enter, and what that does is it runs the cell and it automatically moves to the next cell below it. And if you're at the very last cell, it's going to automatically enter, insert new cells. Okay. Alt Enter or Option Enter will run the current cell and then insert a new cell right below it. So just some examples here. Like if I have x equals 5 and I hit Shift Enter, it runs it and it does it enters the next cell, and it can say print x, and it hit Shift Enter and it runs to the next cell. Okay. I can go here, and if I say, well, you know what, I actually want to insert a new cell, I can hit the letter B to insert a new cell below, and I can say x times 2. And then instead of hitting Shift Enter, I'm going to go ahead and hit Alt Enter. So on my, you can't see it, but you'll have to listen to me. Alt Enter, and it's going to. Is this not working? Alt Enter. Okay. It's going to run execute it. It prints out the number 10, or outputs the value 10, and then it inserts another cell ready for me to type in more stuff. Okay. X times x, Shift Enter, execute it, and then move to the next cell. So these are just some basic things that we can do as far as running the cells. So one thing to note is that when you use Jupyter, it runs something called Ipython. Okay, so as far as, I don't know why this is being rendered kind of a little bit funny like this, but as in Ipython, You do basic operations like 2 plus 3 and it shows up as such. Is this just a... Okay. And if you put multiple operations in here, so here I have 4 plus 5 and 5 times 5, okay, only the last operation is output, okay? So, so it technically computes this. It computes a 9, but then the output of the cell is going to be 25, okay? If you run commands like print, where part of the command requires things to be output to the screen, then both of those things will get output here. All right. So one thing you'll note is that when you run, when you include a cell, if you have an in, sometimes there's an out. Sometimes it says out 2, but down here there's no out 3. Okay, and that's because print doesn't return a value. So if the function returns a value, you get an out. If it doesn't return a value, such as in Python, print, it returns a none, okay, or basically a null value. And in Python, you're not going to get an out, okay. So the things that we've been working with, we can actually refer back to certain things. So my first input, I typed in basic operations 2 plus 3. And if I want to refer back to that very entry, I can do that. I can say, what is in square bracket 1? Kind of like referencing a list here. And so I can say, all right, what did I write in 1? If I come over here and I say, what was in 1? It's going to tell me that the text that I entered there was the text 3 plus 3. Okay? And I could ask, what was the value that was output for output number 4, okay? So I can say, what is out 4, okay? And it says, oh, you know what? The value that output 4 produced was the number 36, right? So you can reference kind of past values in your notebook using this kind of dictionary. And this applies to things that that we deleted. So I think early on I made a mistake and I tried using an exclamation point for factorial. And I think that was input 2. So I can say, what was input 2 again? And so even though I deleted that, it's still part of the kind of the record, okay, as far as this current session is running, okay. Some of these things, like number 7, there's no out 7. So if I ask, hey, what is out 7? Because input 7 was print x, and print x doesn't return anything. So I can ask, hey, what was output 7? Okay, it says there's an error. There's like this key doesn't exist. Okay, because internally it's being stored as a dictionary, and if you try to look up a value in a dictionary that doesn't exist, you get an error. You get a key error that says, oh, you know what, this entry doesn't exist. So. But you can reference these things, and you can use square bracket 1, square bracket 2 to kind of reference like what was the thing that I typed in, right? So input 1 generally will always be surrounded in quotes because it's taking the literal expression that you typed in, including new lines. So I wrote basic operations and then I had a new line, and so that shows up as a /n as a new line character to kind of say like these are the things that you typed in. Okay. The outputs, again, is stored internally as a dictionary. We'll talk about dictionaries, but dictionaries basically have keys that you can look up and the associated value. And so some of these things don't have associated values, whereas in is a list, and you can kind of express all of these things. So this is the list that we've created so far. You can do a few things. I've totally forgotten. I got to give you view quiz answers. This is like my weakness. Let me go ahead and give you your first 2 view quiz answers. First 2 view quiz answers are the letters A and B. A as in apple, B as in bear. A as in apple, B as in bear are your first two Buchla's answers, A and B. All right, so here, like Python does this weird thing with strings. I don't know if it's a weird thing. It's just part of the Python philosophy. It treats strings as what we call iterables, and then it allows math operations with iterables. So you can do this with not just strings, but also any kind of iterable, such as a list or a dictionary. Well, but yeah, lists and strings. So you can do 3 times the string hello, and then it goes hello, hello, hello. Right? So that feels a little bit weird, like doing math operations with strings, but you're allowed to do that. You can take 2 strings high and then do plus. Plus will concatenate these 2 things, and so you get hi and goodbye kind of just tacked on together, and that works for strings and lists and stuff as well, actually. But this is what we have. Okay, so you can kind of do these math operations. Within Jupyter, you can also execute scripts. So inside my in Jupyter Lab, I can open up this script. All right. So this script is like super basic. It just has one line and it just says print hello world in the script. And if I wanted to execute that, okay, I can run this command %run. And I type in the name that I want to run. So script01.python, and it executes the script there. Okay, it executes the script. Script 2, there's a place for a variable. So it's going to do hello plus name, and I wrote it's Friday. It's Wednesday. Okay, so maybe I'll update this. It's Wednesday. All right, so I'm gonna save that. And here, and if I do this, if I do %run, here actually let's establish name equals miles. Okay, and now I want to run this. Okay, I can do %run script02.py. If I try to do this, I get an error. It says name is not defined. Okay, and that's because normally when you do %run and you give it a script name, it runs the script in kind of its own little environment that doesn't have access to the values inside your notebook. If you want to give it access, so I'm going to just copy. Whoops. You can give it the options %i or -i. Okay, -i says I'm going to give you access to the variables in my notebook. And so here I've got miles established here, and so now it runs the script and says hello miles, because it's running this thing where it just takes hello and it tacks on the name and it prints that out. Okay, so that's so you can execute scripts from inside Jupyter. So if you want to like write a script with some commands and whatnot, you can do that, and then you can execute them from inside your thing. All right, so this is the example that I've done here. Name not defined, and it runs. Okay, you can also run some basic shell commands. So if you wanted to see the contents of your script, if you're running Mac OS, the command will be cat. Cat will execute this, whereas on a Windows machine, the command is type. Okay, so it's a little bit weird, and you just you do a exclamation point, and that allows you to run kind of access some of these internal commands. So you can do type script02.python, and it will type out whatever the contents of that file is. Okay, you can always refer to the last value that was output. So here I did 3 times 9. It outputs 27. If you want to refer to the last value, you can just use the underscore character. The underscore character. And here I did underscore, so the last value -2. And that outputs the number 25. And if you just type in the underscore, it gives you, again, the last value here. Underscore gives me 25. So these are just features that exist inside interactive Python. So the base Python interpreter won't allow you to kind of do these kinds of things, but Ipython, which comes with these in and outs and these square brackets and stuff, allows you to do some of these things. So it's basically the Python interpreter, but with some of these added features, which make it a little bit nicer and easier to work with. And all right, anytime you want to ask for help, which is very important, these give you the kind of the document or your manual pages, the man pages. You can just type in help with the name of any function. So here I can say, what is print? Help print, and it gives you all kinds of stuff, right? So an important thing, and I don't know if I didn't explicitly assign this as like homework, but in order to become better at coding and programming and in general, you need to be able to learn how to read help pages, okay? The manual pages. So you need to be able to read them and start to learn and understand. And they're all written in a certain structure, and in the beginning it feels like foreign, but then after you start reading a bunch of these, you'll get accustomed to the kinds of help that it produces. And it always kind of starts off with what are the arguments that the function takes in, and the specifics of each of those arguments and the specifics of the output. Rather than, in a lot of cases, you're going to always have access to the internet, and you can always kind of search the internet and Stack Exchange for all of these things. But the quality of responses on different websites vary, and sometimes like bad advice is given and things like that, okay? Whereas the documentation, at least for the base Python set, is very high quality, and it's not going to give you incorrect information, right? The same can't be said about every single optional kind of package or module that's out there. Some of those aren't documented well, but at least as far as like your base Python, your NumPy and your pandas and things like that, all of those that documentation is going to be very high quality. So get in the habit of anytime you encounter a new function, read some of the help, okay? Some of the help entries are very long, but start getting used to it. Okay, so some notes about Python syntax, and we will start getting just established in working with Python. Before I forget, let me give you your last view quiz answer, which is the letter E. E as in elephant. E as in elephant. Okay, comments in Python are marked with a pound sign. I wonder if something's just... Yeah. All right, I have to figure out how to do this. Okay. So you write a pound sign, so very similar to R in that regard, regarding comments. And then the end of a line terminates a statement, so also similar to R there. You don't need to use a semicolon, but you can if you wanted to. Like if you wanted to put two lines of code, separate lines, you can do this. Okay, you can put a semicolon in between there to include multiple statements in one line. Okay, and if you have like a long statement, all right, let me just go through the notebook itself. Oh, geez, something happened here. Okay, so if you want to have a line continue across a statement continue across multiple lines, you can use a backslash and you can have it continue on, or you can wrap the entire line in parentheses or things like that. Okay, some things just naturally will continue over multiple lines until it reaches the ending kind of statement. So here I'm establishing a list, and we'll get into lists later. but here I have an opening square bracket to start a list, and it's going to kind of accept multiple values until it encounters the closing square bracket there. One thing that's unique about Python is that the code is inherently tied to indentation, right? So in a lot of other languages, indentation is not required. It's like nice, but you can just like use curly braces and you don't necessarily need to indent your next lines. And probably you might have had instructors in the past that said it's important to indent so it's easier to read, but technically the code would run. In Python, that's not the case. If you don't indent, your code will operate differently. Okay, so indentation is very much tied to the code itself. And it feels a little bit strange, and there's, like how much indentation do I do, and do I do tabs or do I do spaces? That part doesn't matter as much, but you need to establish certain like levels of indentation, and it's very much related to that. So here I have an if statement. And we're going to have x equals 8. If x is greater than 5, colon, so these are the lines that are associated with this if statement. The indented lines are associated with the if statement. So if this is true, if x is greater than 5, and for x equal to 8, this is true, this line will run, and then this line will run. Okay, these two are tied to the if statement. Okay, this print hello is not tied to the if statement. So when I execute this code chunk, I get x is greater than 5. That prints out the value x is printed out in hello. If I change the value to 4, these two statements, this is not true, so neither of these statements are executed. Okay, because the if statement is false, so if it's false, it just doesn't execute those lines of code. Now here, if I take this exact same code chunk, the only difference between this code chunk and the previous code chunk is that I changed the indentation level of this print statement, right? So here, I'm going to just copy this statement, okay, this cell, and all I'm going to do is I'm going to delete the indentation here. Okay, so if I delete the indentation, this is no longer associated with the if statement. So even though this is not true, it's not going to execute this, but it's going to execute this no matter what because it's not associated with the if statement. So when I run this, it's going to print out 4, it's going to print out hello. Okay, so indentation plays a very important role in Python, and you're going to encounter errors if you have things indented where it's not supposed to be. Like if I have print x and print hello, and if I just decide to indent print hello, it's going to say, what are you doing? Okay, unexpected indent. Why is this indented? Okay, and it only allows for indentation if there's some kind of code line associated to it, like an if statement or a for loop or something like that, right? So if you can't just indent things just for fun, because indentation carries significant meaning here, right? So so anyway, that's just some very introductory basics to Python, yeah, we'll end here for today, and then we will see you on Friday.